Analytical geometry is a branch of mathematics. It's all about studying geometric shapes. We use a coordinate system to do this. This lets us describe lines and shapes with numbers. Cool, right? This approach bridges geometry and algebra. It provides us with powerful tools to solve problems. Imagine trying to describe a triangle without drawing it. Difficult, right? Analytical geometry makes it easy. We can represent the triangle's corners as points on a coordinate plane. With these points we can calculate the triangle's sides, area, and more. It's like magic, but with math. Analytical geometry is super useful. Architects use it to design buildings. Computer programmers use it to create video games. It is even used in physics and engineering. The Cartesian plane is like a giant grid. It's named after René Descartes, a famous mathematician. The plane has two axes. The x-axis is horizontal. The y-axis is vertical. They intersect at a point called the origin. Every point on the plane has an address. We call them coordinates. Coordinates are written as x, y. The x value tells us how far to move left or right from the origin. The y value tells us how far to move up or down. Think of it like a treasure map. X marks the spot, only tells you one direction. But if I say, go 3 steps east and 2 steps north, you'll find the hidden treasure. The Cartesian plane is similar. It helps us pinpoint the exact location of any point. Let's talk about distance. In analytical geometry, we can find the distance between any 2 points. We use the distance formula, the square root of x2 x1 squared plus y2 y1 squared. It looks scary, but it's not that bad. Let's say we have 2 points, A, 1, 2, and B, 4, 6. To find the distance, we simply plug the coordinates into our formula. After a little calculation, we get the square root of 4, 1 squared plus 6, 2 squared equals the square root of 3 squared plus 4 squared equals the square root of 25 equals 5. The distance between A and B is 5 units. Now what about the midpoint? The midpoint is the exact middle point of a line segment. We can find it using the midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. It's like finding the average. Using our previous points, A, 1, 2, and B, 4, 6. The midpoint would be 1 plus 4 divided by 2, 2 plus 6 divided by 2, which gives us 2.54. That's the midpoint of the line segment AB. Lines are fundamental in geometry. In analytical geometry we can represent any line with an equation. The most common form is the slope-intercept form, y equals mx plus c. In this equation, m represents the slope. The slope tells us how steep the line is. C represents the y-intercept. The y-intercept is where the line crosses the y-axis. For example, let's say we have an equation y equals 2x plus 1. Here the slope, m, is 2, meaning the line goes up 2 units for every 1 unit it moves to the right. The y-intercept, c, is 1, meaning the line crosses the y-axis at the point, 0, 1. See, analytical geometry isn't that scary. By understanding these basic concepts, you can unlock a whole new world of geometry.